Hi guys, Mark Van here with another episode of Science Made It. Today we're going to be talking about motors. Now in physics and engineering, a motor is a machine that can convert one form of energy into useful rotational energy. In a car, the engine converts the chemical potential energy of gasoline into the rotation of the wheels to allow the car to move. Today, we're going to be making a simple electrical motor that converts the electrical potential energy of a battery into the rotational energy of a small copper wire or a screw. To get started building our simple electric motor, we're going to need one AA battery, a set of needle nose pliers, a screw, hopefully nothing too big, and a set of rare earth magnets. Now you can get these at pretty much any hardware store, electronics store, or even hobby store. Nice. Quick note on safety, guys. Rare earth magnets are extremely powerful, and they can actually pinch and hurt quite a bit if you get a body part like a finger or a nose stuck in between them. So always be careful when you're using them and always use them under adult supervision. To build our electrical motor, we'll need to start by stripping the insulation off of the end of a short length of copper wire. We can then take the rare earth magnets, I use about 3 of them, and attach them to the end of the screw. Take your AA battery and dangle the screw and magnets from the flat end of the battery, or the negative terminal. Once you have it pretty much centered up, all you need to do is connect the copper wire to the top, hold it down, and then press the wire to the bottom. And right away, you should see the screw magnet start to spin. So how is it that our simple electric motor is able to turn? When we run a current through a wire, as we did by connecting the 2 ends of our motor, it produces a magnetic field. Now in the case of our machine here, the magnetic field of the wire is running perpendicular to that of the magnet and the screw. Whenever you have 2 electric fields running in perpendicular directions, you create what's called a Lorentz force. And this force causes the screw and the magnets to rotate. An alternative kind of simple electric motor allows the coil of copper wire to rotate instead of the magnets. So in this case we have what's called a static magnet. We attach the magnets to the positive terminal of the battery, lay it flat on the ground, and use a length of copper wire that's been shaped to turn around the battery, placed over top. And if everything's properly balanced, black magic. One of the great things about working with motors is that they demonstrate the principle of conservation of energy. That states that energy can neither be created nor destroyed, only converted from one form to another. So in the case of our simple electric motor, we were converting the chemical potential energy of our battery into the rotational kinetic energy of our coil or of our screw. Now this principle can also be run in reverse. So with this example here, we're turning the rotational kinetic energy of a crank through a generator into electrical energy, which is causing the light to glow. Another law of thermodynamics states that you can never convert energy 100% efficiently. You're always going to lose a little bit into a lower form of energy. This is why it wouldn't make any sense to attach a motor to a generator that powered the motor and have perpetual motion, because you're always going to lose some of the energy to a lower form of energy in the form of heat and friction along the way. Well guys, thanks for joining us again for Science Made It. Good luck at home building your own simple electric motors, and we'll see you next time.